A sleek silver sedan glides silently down a rain-slicked highway in Shanghai. The driver glances at the fuel gauge and smiles. They left Beijing yesterday morning, drove 1,200 kilometers through 3 provinces, and still have a quarter tank of gas left. This isn't an electric car. It doesn't have a massive battery pack. It doesn't need to stop for 30 minutes to recharge. This is a regular gasoline-powered car with an engine so efficient it gets 106 miles per gallon. This is the Keilin 1 engine, and it is the single biggest breakthrough in internal combustion technology in the last 50 years. Here are the numbers that will make you question everything you thought you knew about cars. It achieves 45% thermal efficiency. That means almost half of the energy in every drop of gasoline actually moves the car forward. The average American car engine, it wastes 70% of its fuel as heat. It produces 204 horsepower and 320 newton meters of torque, enough to go from 0 to 60 in 7.2 seconds. And it costs just $1,200 to manufacture, less than half the price of a comparable Toyota hybrid engine. Almost every single part of it was designed, tested, and mass-produced by one country, China. But before you ask how, you need to understand why. For decades, the internal combustion engine was a dying technology. The world had written it off. Governments around the globe announced bans on new gasoline cars by 2035. Automakers poured trillions into electric vehicles, convinced batteries were the only future. But there was one massive, inconvenient truth that no one wanted to talk about. 80% of the world's cars still run on gasoline. And for billions of people in developing countries, electric cars are simply unaffordable. Think about what that means. A farmer in rural Brazil can't afford a $40,000 Tesla. A taxi driver in Nigeria doesn't have a charging station within 100 kilometers. A small business owner in India can't wait 8 hours for their delivery van to recharge. For these people, the electric vehicle revolution might as well be happening on another planet. They need affordable, reliable transportation that runs on the fuel they already have access to. And until now, no one was building it for them. The West had given up on improving the gasoline engine. American automakers stopped investing in combustion research back in 2015. European companies shifted all their resources to EVs. Toyota kept tinkering with hybrids, but even they admitted they were just buying time. Everyone agreed the internal combustion engine had hit its physical limit. Everyone, that is, except China. In 2019, a small team of engineers at BYD's Advanced Technology Center in Shenzhen made a decision that would rewrite automotive history. They didn't follow the West down the electric-only path. Instead, they asked a simple question: what if the internal combustion engine isn't dead yet? What if we could make it so efficient it actually produces less carbon dioxide per kilometer than an electric car charged on a coal-powered grid? The goal was insane on paper, but almost poetic in its simplicity. Build a mass-producible gasoline engine that gets over 100 miles per gallon, costs less than $1,500 to make, and lasts 500,000 kilometers without major maintenance. To put that in perspective, the most efficient gasoline engine ever built before this was Toyota's dynamic force engine, which tops out at 41% thermal efficiency and 58 miles per gallon. The best American engine, 37% efficiency and 42 miles per gallon. Before they could design a single piston, before they could cast a single engine block, the engineers had to confront a problem that had stumped every automaker on Earth for 100 years. The biggest enemy of engine efficiency isn't friction, it isn't weight, it's heat. Every time gasoline burns inside an engine, 70% of the energy turns into useless heat that gets blown out the exhaust or radiated through the radiator. For a century, engineers tried everything to capture that heat. They added turbochargers. They built hybrid systems. They used fancy materials. But they all hit the same wall. The hotter the engine runs, the more efficient it is. But also the more likely it is to melt itself into a pile of scrap metal. The Chinese engineers didn't try to fight the heat. They did something brilliant. They embraced it. Most car engines run at a maximum temperature of 90 degrees Celsius. The Keilin 1 runs at 160 degrees Celsius. That's hot enough to boil water 3 times over, hot enough to melt aluminum. To make this work, they didn't use a better coolant. They used no coolant at all. Wait, let that sink in. This is a 204 horsepower car engine with no water cooling system, no radiator, no hoses, no water pump. Nothing. Instead, the entire engine block is made from a new type of ceramic aluminum composite that conducts heat 10 times better than regular aluminum, but doesn't expand or crack at extreme temperatures. Think of it like this. A regular engine is like a pot of water on the stove. You have to keep adding cold water to stop it from boiling over. The Keilin 1 is like a cast iron skillet. It gets screaming hot, but it doesn't break. It just cooks the fuel more completely. But the real magic isn't just in the materials, it's in the tiny, almost invisible details. that add up to a revolution. The engine's fuel injectors spray gasoline into the combustion chamber in 1,200 separate droplets, each smaller than a human hair. The injection timing is controlled to within 10 microseconds, faster than the blink of an eye. The pistons have a special diamond-like coating that reduces friction to almost zero, so the engine loses less energy moving its own parts. Every single component was optimized down to the gram. The connecting rods are hollow, like the bones of a bird, but strong enough to handle 200 tons of force. The crankshaft is forged from a single piece of high-strength steel, then machined to a tolerance of 1 micron, 1,000th of a millimeter. That's so precise, if you scaled the engine up to the size of a football field, the biggest gap between any two parts would be less than the thickness of a credit card. When the first prototype engine fired up on a test stand in 2023, the engineers couldn't believe their eyes. The thermal efficiency reading hit 42%, then 43%, then 44.8%. They thought the sensors were broken. They ran the test again and again and again. Every single time the number came back the same. They had just broken a record that had stood for 20 years. And they weren't even done yet. Over the next 2 years, they tweaked and refined every part. They improved the turbocharger. They optimized the valve timing. They added a tiny 48-volt mild hybrid system that captures energy during braking and uses it to help the engine accelerate. By the time they were finished, the thermal efficiency had climbed to 45.2%. And the fuel economy? 106 miles per gallon on the highway, 89 miles per gallon in the city. That is not a small improvement. That is a complete transformation of what a gasoline car can be. The numbers tell the full story. A car with the Keilin 1 engine can drive 1,500 kilometers on a single 50-liter tank of gas. That's from New York to Chicago on one tank, from London to Rome on one tank, from Beijing to Shanghai on one tank. It produces 60% less carbon dioxide per kilometer than the average American car. And even when you account for the emissions from producing and refining gasoline, it's still cleaner than an electric car charged on a grid that gets 60% of its power from coal. But the real impact isn't in the test numbers. It's in what this engine means for ordinary people around the world. A taxi driver in Mexico City who used to spend $50 a day on gas will now spend $15. That's an extra $12,000 a year in their pocket. A family in Kenya who could never afford an electric car can now buy a new sedan that costs $10,000 and costs almost nothing to run. A delivery company in India can cut their fuel bills in half overnight, allowing them to lower prices and hire more drivers. This engine didn't just make cars more efficient. It democratized affordable, clean transportation for billions of people who were being left behind by the electric vehicle revolution. Is the technology perfect? No. Critics point out that it's still a gasoline engine, and it still produces carbon dioxide. The ceramic aluminum composite is more expensive to recycle than regular steel. And Western automakers are already crying foul, claiming China is unfairly subsidizing the technology to dominate the global market. But here's the thing. No one is talking about. China isn't keeping this technology to itself. They've already licensed the Keilin 1 design to 12 different automakers in 8 countries. They're building engine factories in Brazil, Nigeria, and Indonesia. They're selling the engines at cost to developing nations because they understand that the biggest market for this technology isn't in Europe or America. It's in the global south. In terms of the scale of the breakthrough, the speed of development, and the sheer impact it will have on billions of lives. The Keilin 1 engine stands as one of the most remarkable technological achievements of the 21st century. It proves that sometimes the best innovation isn't about replacing an old technology with something completely new. It's about taking something everyone thought was dead and making it better than anyone ever imagined possible. If you made it this far, you just learned about a breakthrough that will change how the world moves. You saw how Chinese engineers beat impossible odds, solved a problem that stumped the West for 100 years, and created a technology that will lift millions out of poverty. All without sitting through a single boring engineering lecture. That is what this channel is all about. Breaking down the world's most incredible feats of human ingenuity in a way that makes you feel like you're right there, in the lab, watching history happen. If that sounds like your kind of content, hit the subscribe button and turn on notifications so you never miss our next deep dive. Do you think the internal combustion engine still has a future, or is electric still the way to go? Drop your answer in the comments below.